Hello, today is Friday, January 19th, 2024. I'm Sarah Krifasi from LB3, and this is Staying Connected. Today, we're going to discuss a few emerging technologies, and no, not AI this time. Instead, we'll cover three technologies that may not be in front of mind for CIOs. First, we'll discuss the latest news on low Earth orbit, or LEO satellites, then fiber-based broadband services delivered via passive optical network technology, and finally, wave services. And to lead this discussion, I'm joined by TC2's Technology Director, David Lee. Thanks so much for joining me today, Dave. We haven't covered satellite and particularly LEO satellites in prior podcasts. So to start, why don't you provide our listeners with some background on what enterprise clients need to know about satellite services?
Sure, and good afternoon, Sarah. Let me start with an overview on satellites. Geostationary satellites have been around for over 60 years now, and thanks to their size, transmit power, and extreme distance away from Earth, that is 22,000 miles, it actually only takes 3 geostationary spacecraft positioned equidistant around the Earth for their signal to cover the entire surface. They are called geostationary because they stay over a specific longitude 24 hours a day. However, this distance from Earth does mean their connection has high latency, plus they are expensive to produce and send into orbit. To give you a simple example, for a signal to travel to and from a geostationary satellite, it is the equivalent of sending a signal around the Earth 2 times. On the other hand, LEO satellites are best positioned to cost-effectively create connectivity to places that terrestrial systems, either wireline or wireless, have been largely unable to provide.
Thanks, Dave. Can you tell us a little bit more about why we need the LEO satellites and the use cases that apply?
Sure. According to recent studies, approximately 15% of the U.S. population is too rural for effective wireline or cellular coverage, and there are many areas of the world that don't have sufficient terrestrial coverage. One of the key benefits of the LEO satellites, due to their much lower altitude and advances in software-defined radio technology, they can provide lower latency and bandwidth comparable to broadband terrestrial services. In addition, there are new use cases such as Starlink's and John Deere's recent announcement to have ruggedized Starlink equipment installed on John Deere farming equipment to cover gaps in cellular coverage. This will provide John Deere-equipped farmers anywhere in the world for real-time data sharing, remote diagnostics, and other agri-services. Another example is if an enterprise needs a backup connection that is completely foolproof and not dependent upon local or regional telecom providers, LEO satellite service provides this.
It's interesting. Okay, so I've been hearing about LEO satellite launches more and more in the news lately. How many LEO satellites are out there and where are they located?
Good questions. The low Earth orbit satellites are about 340 miles above the Earth. That's about 90 miles above the International Space Station, to give you some perspective. From news reports, these LEO satellites are visible to the unaided eye. As of 2023, there are over 7,500 satellites currently circling the Earth at all altitudes. When I say that number, most folks are surprised, and that does not count space debris. Currently, there are 590 operating geostationary satellites, but there are over 6,700 LEO satellites. So LEO accounts for 90% of all operational satellites today. And these LEO satellites have seen massive growth in the past 5 years since Starlink started production launches.
Got it. So who are the top LEO satellite providers and what are their key characteristics?
There are 3 commercial LEO providers. Starlink, a division of SpaceX, has over 4,200 satellites in orbit today and sells directly to consumers, businesses, and government. OneWeb, which was merged with France's Eutelsat, has about 630 satellites in orbit and is a wholesale provider, meaning that it sells to ISPs. And finally, Project Kuiper, which is Amazon's LEO satellite solution, is licensed to launch 3,200 LEO satellites starting this year. Right now, Amazon has 2 test satellites in orbit, and Amazon reports everything is working as planned. In addition, Kuiper also has in front of the FCC a V-band, which is a millimeter wave band, satellite constellation to take that number up to 6,000 satellites longer term. What's significant is that both Starlink and Kuiper use inter-satellite cross-link connections among their many thousands of satellites. This allows them to transmit a packet from satellite to satellite without going back to the ground. For example, this could mean a packet can travel thousands of miles as the crow flies without the need to take the significant twists and turns of terrestrial fiber and delays caused by intermediary equipment, as well as transiting different carriers and points of presence. In fact, Project Kuiper recently stated that its satellite constellation will be able to move data around 30% faster compared to terrestrial fiber, sending data along an equivalent distance by using a technology called optical intersatellite links, or OISL. It's optical communication that uses lasers to send data between satellites. In addition, light travels faster in space than it does through fiber optic cables. Now, OISL has been around before to enable intersatellite communications, but it was limited to linking just two satellites at a time. Kuiper satellites will be able to connect with many other satellites simultaneously to form a mesh network in space. Now, Amazon said it has completed tests with its intersatellite laser connections, maintaining 100 gigabit per second links at a distance of over 620 miles. This is very impressive, given the tight tolerances for the beams, and the satellites are moving at 17,000 miles per hour. We need to move on, but we could discuss pricing, bandwidth, equipment costs, service levels, and other areas in a future podcast, or come to one of our in-person conferences where we can discuss this.
That's a really good overview of the LEO satellite tech. So let's switch gears. And what can you tell us about fiber-based broadband and passive optical network technology?
Sure, Sarah. Fiber-based broadband and optical network technology has been around for many years, but deployed sporadically and opportunistically. For example, Verizon deployed its trial Fios service 18 years ago in Texas. However, Verizon stopped its Fios expansion 5 years later in 2010. It has since restarted it, though. What has changed is a number of factors. For example, new architectures and standards, new broadband providers driving competition, new technologies with lower costs, and government programs such as the $42 billion Federal Broadband Equity Access and Deployment, or BEAD for short, initiative. The BEAD program's goal is to have a minimum of 100 megabits downlink and 20 megabits uplink speeds for all 50 states, Washington, D.C., and U.S. territories. This funding will drive new fiber-based broadband to many communities and enterprise locations that were underserved. In addition, new passive optical network standards and technology have become mainstream and cost-effective as more providers are deploying this tech. For example, something called NG-PON2, PON number 2, or Next Generation Passive Optical Network 2, is a 2015 international standard providing symmetrical 40 gigabits per second down and up speeds, and is compatible with the prior PON standards, which provided symmetrical 10 gig up and down speeds. Verizon, as one example, is deploying this NG-PON2 technology. These initiatives and technologies are all good news for our enterprise clients as they seek and need more internet bandwidth that is cost effective.
Absolutely. So what are your thoughts for wave services?
Well, optical wavelength service, or WAVE services for short, is a point-to-point WAN service connecting to location. Waves are meant for high-capacity WAN service needs, with most carriers offering services up to 100 gigabits, but also are provided at lower speeds such as 1, 5, and 10 gigabits. Waves are also ultra-low latency in that they are layer 1 and layer 2 links. These characteristics make them great choices for transmitting large amounts of time-sensitive data or transferring information between data centers or hubs. Several enterprises have recently decided to deploy wave services instead of traditional WAN services like MPLS or dedicated internet for some parts of their network. Given the continuous advances in optics, such as dense wavelength division multiplexing or DWDM technology, the price per gigabit has come down sufficiently in certain countries and global regions so that enterprises should consider wave services.
All right, that is great stuff. Thank you so much, David. These three emerging technologies can certainly make an impact by filling gaps in and supporting new use cases and business applications for enterprises. And if you'd like to learn more about these services or you have other ICT needs, you can contact Dave, me, or any of our LB3 and TC2 colleagues by giving us a call or shooting us an email. You can also always stay up to date by subscribing to Staying Connected, by checking out our websites, and by following us on LinkedIn.